Mars, our red neighbor, has captivated our imaginations for centuries. We look up at its rusty surface and dream of a day when humans might walk among its canyons and volcanoes. But Mars holds a secret, a chilling truth that stands between us and our dreams. Mars is cold, brutally cold. Its thin atmosphere offers little protection from the sun's harsh rays. The average temperature is a bone-chilling -80 degrees Fahrenheit. Turning this frozen wasteland into a habitable world seems like a challenge straight out of science fiction. Yet the human spirit thrives on challenges. The dream of terraforming Mars, of transforming it into a second Earth, has inspired scientists and dreamers alike. Countless ideas have been proposed, each aiming to unlock the hidden potential of the red planet. Some have suggested bombarding the poles with nuclear weapons to release trapped carbon dioxide. Others have proposed giant orbital mirrors to focus sunlight and melt the Martian ice caps. Each idea, a testament to our boundless ingenuity, a reflection of our yearning to reach beyond the confines of our own world. In the annals of scientific exploration, breakthroughs often emerge from unexpected corners. A recent study published in the esteemed journal has ignited fresh excitement in the quest to terraform Mars. A team of researchers from Harvard University, the University of Chicago, and NASA's Jet Propulsion Laboratory have unveiled a revolutionary method that sounds almost too simple to be true, using dust. But this isn't just any dust. The researchers propose using silica aerogel, an extraordinary material with remarkable properties. Silica aerogel is incredibly lightweight and porous, resembling a frozen cloud. It's also an exceptional insulator, capable of trapping heat with astonishing efficiency. The team's idea is to create a thin layer of this engineered dust over strategic areas of Mars. Could this be the key to unlocking Mars's potential and transforming it into a more hospitable world? Imagine a fine layer of silica aerogel like a delicate blanket spread across the Martian surface. This engineered dust, strategically positioned, could act as a thermal shield, trapping the sun's warmth and raising temperatures beneath it. But how exactly does this work? Sunlight, as we know, carries energy in the form of light and heat. When this sunlight reaches the Martian surface, it's mostly reflected back into space, contributing to the planet's frigid conditions. However, the silica aerogel acts like a microscopic greenhouse. Its porous structure allows sunlight to pass through, but it traps the heat that's generated when the sunlight is absorbed by the surface below. This trapped heat creates a localized warming effect, raising temperatures enough to potentially melt subsurface ice and release trapped carbon dioxide. As the atmosphere thickens, a chain reaction could begin. A denser atmosphere would further insulate the planet, leading to a runaway greenhouse effect that could, over time, transform Mars into a more temperate and habitable world. Section 4. A new dawn for terraforming? The beauty of this new method lies in its simplicity and potential feasibility. Previous terraforming ideas often involved large-scale, energy-intensive processes, like transporting vast amounts of greenhouse gases from Earth or building massive orbital structures. The silica aerogel method, in contrast, relies on a relatively small amount of material and harnesses the power of the sun, which is abundant on Mars. Edwin Kite, an assistant professor of geophysical sciences at the University of Chicago and one of the study's authors, explains, "We found that a thin layer of this material, just a couple of centimeters thick, would be enough to raise temperatures permanently above the melting point of water." Samaneh Ansari, a postdoctoral scholar at the California Institute of Technology and the study's lead author, adds, "This is a very exciting possibility because it offers a more achievable and sustainable approach to terraforming compared to some of the more ambitious ideas that have been proposed in the past." Section 5. Echoes of Past Visions. The idea of terraforming Mars is not new. It has captivated the minds of scientists and science fiction writers for decades. In the early 20th century, visionary thinkers like Carl Sagan first proposed the possibility of transforming Mars into a habitable world. Sagan, with his infectious enthusiasm and eloquent prose, painted a vivid picture of a future where humans might one day call Mars their second home. His writings inspired generations of scientists and engineers to tackle the challenges of space exploration and planetary engineering. Over the years, countless ideas have been proposed, each pushing the boundaries of our understanding and technological capabilities. From bombarding the poles with nuclear weapons to deploying giant orbital mirrors, the quest to terraform Mars has been a testament to human ambition, and our unyielding desire to push the boundaries of the possible.